Welcome to this fabulous new experience of Algebra 2 Trig with Mr. Harold Higgins
Miss Jenny Albrecht
and
Mr. Forrest Higgins.
perfect. So we're going to do our lessons jointly, and today we are going to listen to the words of the fabulous Forrest Higgins, and we are going to talk about lesson 14.1 and some trigonometric ratios.
Sokotoa.
All right. Hi, Algebra 2. Today we're looking at 14.1. We're looking at our trig ratios. We're going to talk about our main three trig ratios, our sine, cosine, and our tangent. Our inverse trig ratios, and we'll get to those in a second. Okay, first thing, hopefully this review for us with the sine, cosine, and tangent. You've seen this in geometry. Okay, we have a little acronym, SOHCAHTOA. S, sine, is opposite over hypotenuse. COA, cosine, adjacent over hypotenuse. And TOA, tangent, which is opposite over adjacent. Okay, the real important thing to know is we need to identify the acute angle that we're going off of in order to have these ratios. And we'll usually call that theta right here. So from here, the opposite is across. If our theta was up here, this would actually be our opposite. You see how that works? It goes across to opposite. So we have our theta, and opposite is here, and adjacent is next to it. Okay, the hypotenuse is never going to change. It's always the opposite of the right angle. Okay, so we have our sine, our cosine, and our tangent. Again, yes?
Mr. Higgins,
Yeah.
I don't quite understand the whole thing of adjacent. How do you really know if it's adjacent?
Adjacent, typically students, I find, confuse the adjacent with the hypotenuse. So what I usually do is identify the hypotenuse first, and then the opposite, and then my remaining angle would be the adjacent. But it's simply the angle that is next to, or excuse me, the side that is next to our angle that is not the hypotenuse.
So in other words, it helps form that angle.
That's true.
Yeah.
Yeah. Okay, so now what we're going to talk about, we need to start over there.
Go ahead.
Okay, so we're going to start with our sine, which we know the sine of theta is the opposite over hypotenuse. Okay? The reciprocal of that would be our cosecant, and we'll use C as C of theta. And reciprocal is just that, flip it, okay? Which will be hypotenuse over opposite. That is the reciprocal function of our sine. The next one would be cosine. Cosine of theta is our adjacent over our hypotenuse. Okay, the reciprocal function of that is called a secant. And it looks like that, S-E-C. Okay, and that would simply be the hypotenuse over the adjacent. And then we have our tangent of theta, and that is our opposite over adjacent. The reciprocal of that is called a cotangent, and we'll use C-O-T. And that will be adjacent over opposite. One way I use to remember this is that everything has a co. So you have sine, cosecant. Cosine already has its co. Then the reciprocal of that is secant. And then we have tangent and cotangent. Okay? One thing we're going to be able to do here by the end of the lesson is I will give you a trig ratio, say a cosine, and I'll ask you to be able to fill out the rest of the 5 trigonometric ratios. And we'll get to that in just a moment. Hi, welcome back. So what I'm going to do is give you a cosecant and ask us to fill out the rest of the 5 trigonometric ratios. Okay? So if I had, a cosine. If I had a cosine of theta equaling 3 over 5, what are the other 5 trig ratios? And here's how I would attack this problem. I would draw a right triangle. label the right angle and label theta. And we know that cosine is our adjacent over hypotenuse. So I'm going to go here and find the adjacent and the hypotenuse. Okay, and this is clearly not going to be to scale, but we'll worry about that later. Okay, now I need to find my third length of this right triangle in order to get all the information I need. And we're going to go back to our a squared plus b squared equals c squared. And I'm actually going to change this a little bit because we're going to be dealing with trigonometry, which is going to put this on an xy coordinate plane. So anything I see going side to side, I'm going to call x. Anything I see going up and down, I'm going to call y as my unknown. And my hypotenuse, I'm going to call a radius, r. Okay, we'll get back to that later in next chapter probably. Okay, so I'm going to fill this in. I've got 3 squared plus y squared equals 5 squared. And some of you know this is a 3, 4, 5 special right triangle, but we'll do the math. 9 plus y squared equals 25. Subtract the 9 over, and I've got y squared equals 16, and y equals 4. Okay, so I have 4 there. Okay, now I have my opposite, my adjacent, and my hypotenuse. Yes?
What is that a squared plus b squared equals c squared? What's that? What's the name of that?
That's called the Pythagorean theorem.
Perfect.
It's one of the oldest theorems in all of mathematics. All right, here we go. So now I'm just going to go sine of theta, cosine of theta, and tangent of theta. Okay? And I'm going to remember my SOHCAHTOA. Sine, opposite, over hypotenuse. Cosine, already given, but I'm going to redo it. Adjacent over hypotenuse. And tangent, opposite, over adjacent. Okay? Those are my 3 trig ratios. Now I'm going to simply do my reciprocal trig ratios. Sine, everything needs a cosecant. C as C. And I'm just going to look at this and go reciprocal. 5 over 4. Cosine already has a so that one's going to be the secant. 5 over 3. And tangent will have the cotangent. 3 over 4. Okay? So that's how we would get. Now we're going to take a look at this same triangle, but I'm going to go off of not theta, but another angle. The other acute angle off of here. I'm going to call it beta. Okay? So watch how these all change as I go from angle beta. So I would identify the sine of angle beta equals, and for this one, I look at that and I see opposite is being across here. My hypotenuse never changes. It's still a 5. So I would have 3 over 5. And then cosine of beta would equal, from here, adjacent is the 4, hypotenuse is always the 5. All right, then we go to tangent. The tangent of beta equals the opposite over the adjacent. So we have 3 over 4.
Now, Mr. Higgins, I'm noticing that the sine of beta is the same as the cosine of theta. Will that always be the case?
That will always be the case. Yes.
Okay, and I'm also noticing that the tangent of theta and the tangent of beta, they're just the reciprocals of each other. Is that correct?
It's true, and it'll always be true.
Wow.
Because
Okay.
we're limited to just the one other angle in this right triangle.
Yeah,
Okay?
Yeah.
So those will always be the case in the same right triangle.
that's excellent.
Yeah, very good.